Hello, good morning to all of you. I'm Ms. Vandana Gupta, Assistant Professor of Mathematics. I welcome you all to my class. So today we are in the last unit and the last topic of the last unit. Okay, so that is linear programming problem. See, so far what we have done in linear programming problem, we have seen what is a general form of linear programming problem and how to solve the linear programming problem if it is given to you. Problem will be given to you and you how to solve it by graphical method. So this is what we have seen so far. Today what we are going to do, we are going to formulate a linear programming problem. With some data will be given to you, and with that data we will convert that data into a linear programming problem, and then solving the linear programming problem already we have seen in the last few lectures. Okay, so today's lecture will give you an idea ki linear programming problem, where it is used, what is the application of this. As I told you before also, when I started with the first lecture of linear programming problem, in the introduction I told you that the application of linear programming problem is to in many like factories and manufacturing plants, because in every business the purpose or the aim of the business is to maximize the profit and to minimize the cost of production. So today we will see how to maximize, how to convert a real life situation into a linear programming problem. So that is what is our today's topic. Look at here, formulation of linear programming problem. So you will be given some situation and you are going to convert that real life situation into a linear programming problem. Some data will be given to you. So let us read this question. Look at here. Food X contains 6 units of vitamin A per gram and 7 units of vitamin B per gram. You know that the food which we are eating, it contains vitamins, right? We need vitamins and minerals for our body, and that how we get by eating foods, correct? Because each food has got some amount of vitamins which are essential for our body. If a particular person is not getting the required vitamins and minerals from the food which he or she is eating, then doctors give supplements, I mean in the tablet form. Then they have to eat vitamin tablets if you are not getting from the food, you know that. Okay, so let us look at this question. There are two foods in this question, X and Y. So food X contains 6 units of vitamin A per gram, यानी food X के 1 ग्राम में 6 units of vitamin A है and 7 units of vitamin B per gram. यानी ये food जो X food है, इसमें 6 units of vitamin A है and 7 units of vitamin B है per gram, 1 ग्राम में, ठीक है? And what is the cost of this food? It is ₹2 per gram. यानी 1 ग्राम का कॉस्ट है 2, क्योंकि कॉस्ट भी हमको देखना है ना. Food Y contains 8 units of vitamin A. There is another food Y which contains 8 units of vitamin A per gram. यानी 1 ग्राम में 1 ग्राम food Y खाने पर 8 यूनिट विटामिन A का मिलता है and 12 units of vitamin B per gram. And what is the cost of this food? It is ₹3 per gram. Okay. So what you have understood after reading from here to here, that there are two foods, X and Y. Food X के 1 ग्राम में 6 units of vitamin A है and 7 units of vitamin B है. और what is the cost of food X? ₹2 per gram. Food Y, उसमें कितना विटामिन A है? 8 units. और विटामिन B कितना है? 12 units. और उसका कॉस्ट कितना है? ₹3 per gram. Now, what is the daily minimum requirement of vitamin A and B? Are 100 units and 120. यानी एक पर्सन को एक दिन का रिक्वायरमेंट कितना है विटामिन का? तो विटामिन ए का है 100 यूनिट्स एंड विटामिन बी का है 120. यानी एक दिन में एक पर्सन को मिनिमम मतलब कम से कम 100 यूनिट्स विटामिन चाहिए, उससे ज्यादा भी हो सकता है, बट मिनिमम रिक्वायरमेंट इज 100. एंड फूड आई मीन विटामिन बी का 120 units. This is the minimum requirement of a person. Now, what you have to do? This much information is given to you. What you have to do? Formulate the linear programming problem to minimize the daily expenditure on these foods. How many type of food X and food Y a person should eat in order to have his minimum daily requirement, and also to minimize his cost, his daily expenditure, expenses on that food. तो उसको फूड एक्स कितना खाना चाहिए और फूड वाई का कितना ग्राम खाना चाहिए in order to meet his daily requirement of 100 units of vitamin A and 120 units of vitamin B, and the cost of food which he is buying, that expenses, that should be minimum. Okay, so how to do this type of, how to formulate that problem? So let us start with the solution. What are we going to do? Let us say that the daily diet of food X and Y for a person is X grams of food X and Y grams of food Y. Suppose the person takes X grams of food X and Y grams of food Y. Okay. So this is what I've written here. X grams of food X and Y grams of food Y. Now, what is the so what am I going to do first? I'm going to make a table like this, because every time I did not read this. If it is in the data is in the table form, it is very convenient for us to read the data. So I'll prepare a table like this. See, what am I going to do? In the first column, I will write the food. Okay. So, there are two types of food, X and Y. Vitamin, and each food has some amount of vitamin in that. So I will write down here vitamin A, in the next column vitamin B, and in the last column the cost of the food. Okay, so this way I'll prepare a table. Look at here, I will read the data and enter the values in the table. So look at here, food X contains 6 units of vitamin A. Look at here, X food contains how many units of vitamin A? 6 units. So here I will write 6. And 7 units of vitamin B. Look at here, vitamin B in food X is 7. Okay. And what is the cost of food X? Rupees 2 per gram. So here cost per gram. In cost will be in rupees. Okay. So it is 2 rupees. So I have prepared the first row. Okay. Similarly, I will enter the values for food Y. Look at the second sentence. Food Y contains 8 units of vitamin A. Food Y, vitamin A, how much? 8 units. So I've written 8 here. And 12 units of vitamin B. So vitamin B in food Y is 12. So I have written here 12. And what is the cost of food Y? It is 3 rupees per gram. So rupees 3 per gram. So I have entered the values in my table. Look at what is the other statement. The daily minimum requirement of vitamin A and B are 100 and 120. So in the last row, I am writing the daily minimum requirement. Look at here, daily minimum requirement. So vitamin A, how much minimum requirement is there for vitamin A? It is 100 units. And for vitamin B, it is, look at this, 120 units. Okay. So whatever data was given to me in the text form, I have converted that data in a tabular form, because table gives me, very convenient way of reading the data. So the same thing I have put in the tabular form. Now I don't have to read this. I can just see from the table and understand. So I have to formulate the linear programming problem to minimize the daily cost of daily expenses or daily cost of food X and Y. So suppose that I say that the person eats or person takes X grams of food X and Y grams of food Y. Look at here. X grams I have written, X grams of food X and Y grams of food Y. Same table is I have copied here. This one. Okay. Here is the table. Okay. Now look at here. What is the cost per gram of food X? It is 2 rupees. Correct. So cost of 1 gram of food X is how much? Is rupees 2. Right. Food X, the cost is 2 rupees. Correct. So therefore, cost of how many grams of food X he is eating? X grams. Cost of X grams of food X will be 2 into X. 1 ग्राम का ₹2 है. If I ask you 2 ग्राम का कितना होगा तो 2 into 2, 3 grams का 2 into 3. Like that, cost of X grams of food X will be 2X. Similarly, cost of 1 gram of food Y is how much? Look at the table. Y food का 1 ग्राम का कॉस्ट है 3 रुपए, ₹3. So if I ask you, what is the cost of how many grams of food Y is taking? Y grams. So cost of Y grams of food Y will be 3 into Y. Okay. And the person is eating both the types of food, X and Y. So what is the total cost? Total cost is 2 into X plus 3 into Y. See, the person is eating X grams of food X, uska cost is 2X, and Y grams of food Y, 3Y. So total cost of that person is 2X plus 3Y. So this cost he has to minimize. This much is his expenses. Okay. So this is the cost function which is to be minimized. And you know that in the linear programming problem, it has 3 parts. First part is the objective function which is to be maximized or minimized. So ये problem में हमको cost है, तो cost or expenses, so that has to be minimized. So this is the objective function which we denote by Z. You know that objective function is always denoted by capital Z. So Z equal to 2X plus 3Y is the objective function. Is the objective function which is to be is the objective function. जब भी कभी आपको linear programming problem दिया है, the very first step is to find the objective function. First part. So this is the objective function which is to be minimized. Which is to be minimized. Okay. So therefore, look at here. I have written minimize Z equal to 2X plus 3Y. Now the next part is what? To get the constraints. Okay. So I have already written the answer here. I will show you how I'm getting this. Okay. Subject to the constraint. So look at this table. See, or if you go back to this, food X contains how many units of vitamin A per gram? 1 gram food X खाने पे you are getting 6 units of vitamin A. Look at here. Vitamin A in 1 gram of food X is 6. And suppose if a person is eating X grams of food X, so how much vitamin he is getting? 6 times X, 6X. Okay. Vitamin A he is also getting from food Y. 1 ग्राम फूड Y खाने पे 8 यूनिट्स ऑफ विटामिन A मिलता है. तो Y ग्राम खाने पे कितना मिलेगा? 8 into Y. Okay, so that is what I'm going to write here. So I hope you have understood this, how I have got the objective function. Now let us see the constraints. So 1 unit of food X contains how many vitamin A? Look at here. 1 unit of food X contains 6 units. 6 units of vitamin A. Therefore, how many units of food X he is taking? X units. So, X units of food X will contain 6 times X. 6X units of vitamin A. Similarly, 1 unit of food Y contains विटामिन ए उसको दोनों फूड खाने पे मिल रहा है तो वाई फूड खाने पे 1 ग्राम खाने पे 8 यूनिट्स मिलता है तो वाई ग्राम खाने पे 8 वाई मिलेगा 1 यूनिट ऑफ फूड वाई कंटेन्स 8 यूनिट्स ऑफ विटामिन बी therefore how many grams he is eating y grams so y units of food y will contain how many 8 into y units of vitamin b so total vitamin a vitamin a we are talking about vitamin A. So 1 यूनिट ऑफ फूड एक्स खाने पे 6 यूनिट मिलता है विटामिन ई का तो x ग्राम खाने पे 6x मिलेगा सिमिलरली 1 ग्राम खाने पे 8 यूनिट्स मिलता है y ग्राम खाने पर 8y मिलेगा तो टोटल विटामिन ए दोनों फूड खाने के बाद कितना मिला टोटल विटामिन ए आफ्टर टोटल विटामिन ए in food A and B. In food X and Y, there are 2 forces. Is how much? Total is 6x plus 8y. Correct? 6x मिलता है X फूड को खाने पे 8y मिलता है Y फूड को खाने पे तो इतना विटामिन ए मिल रहा है बट व्हाट इज द मिनिमम रिक्वायरमेंट विटामिन ए का एक दिन का कितना रिक्वायरमेंट है 100 है तो ये जो फिगर आ रहा है ये जो आ रहा है आपका ये कम से कम कितना होना चाहिए 100 मिनिमम रिक्वायरमेंट ऑफ फूड ऑफ विटामिन ए इज 100 से ज्यादा हुआ तो चलेगा बट इट शुड नॉट बी लेस देन 100 अदरवाइज यू विल बी हैविंग द डेफिशिएंसी ऑफ विटामिन ए so 6x plus 8y has to be greater than or equal to 100 it should be minimum it should be 100 से ज्यादा हो सकता है so this is my first constraint is the first constraint this is how you get the constraints first constraint okay look at here I have written subject to 6x plus 8y greater than or equal to 100 so this is the first constraint in a similar way you can find out the second constraint look at now vitamin B whatever we have done for vitamin A similarly you do it for vitamin B to get the second constraint look at the table 1 unit of vitamin 1 unit 1 gram you can say 1 gram of food X contains 7 units of vitamin B that is what is given to you look at here food X contains 7 units of vitamin B and food Y contains 1 gram of food Y contains 12 units of vitamin. So 1 gram we should say. So let us write down now. 1 gram of food X contains how many units of vitamin B? 7 units of vitamin B. Look at the table. It is what I have written is this. 1 gram of food X contains 7 units of vitamin B. But वो कितने ग्राम खा रहा है? X gram. Therefore, X grams of food X will contain how many units of vitamin B? 7x. मतलब इट इज लाइक दैट कि एक एप्पल खाने पे आपको 7 यूनिट मिलता है विटामिन बी का तो अगर आपने 4 एप्पल खाए तो कितना मिलेगा 7 into 4 ऐसे ही है ये 1 gram of food X contains 7 units of vitamin B तो X gram will contain how much 7x units of vitamin B also and 1 gram and 1 gram of food Y vitamin B he is also getting from food Y. So 1 gram of food Y contains how many units of vitamin B? 12. Contains 12 units of vitamin B. But how many grams he is eating? Y grams. So Y grams will contain how many units? 12 into Y. Okay, grams of vitamin B. So what is the total vitamin D? So total units of vitamin B after eating X grams of food X and Y grams of food Y is how much? Look at here, 7X plus 12Y. 7X plus 12Y. But what is the minimum requirement of this vitamin B? Say, after eating X grams of food X and Y grams of food Y, कितना विटामिन बी मिला? 7X plus 12Y. लेकिन मिनिमम रिक्वायरमेंट कितना है विटामिन बी का? 120 है. सो इसलिए ये जो मिल रहा है विटामिन बी, इट शुड बी एटलीस्ट 120, मिनिमम 120. तो इसलिए ये ग्रेटर देन और इक्वल टू आएगा. 120 से ज्यादा विटामिन हुआ तो प्रॉब्लम नहीं है, इट विल बी स्टोर्ड इन योर बॉडी, बट इट शुड नॉट बी लेस, अदरवाइज you will have to go to doctor and he will, or you might fall sick. Okay, so this is the second constraint, 7X plus 12Y greater than or equal to 120. So these are the two constraints in this problem. There may be more also, but in this question there are only two. So I hope this is the second constraint. You have understood how to get the constraint. This is second constraint. Now, as I told you, in every linear programming there is a non-negative restrictions. So why X and Y cannot be negative? Look at what is my X and Y. X is what? X is the number of grams of food X a person is taking, and Y grams of food Y. So X and Y cannot be negative. You cannot say कि I'm eating minus 20 grams of food X. That will make no sense. No? Either you are eating that food 50 grams or 100 grams, it will be positive, or you are not eating at all, so it will be 0. So the number of grams of food X, that is X and Y, cannot be negative. So therefore, because they represent the number of grams of food which you are eating, it cannot be negative. So X and Y always has to be greater than or equal to 0. So this will always be there in any linear programming problem. So therefore, the required linear programming problem is the first part. Minimize Z is equal to 2X plus 3Y. Cost we want to minimize, right? So minimize the objective function. Subject to these are the constraints: 6X plus 8Y greater than or equal to 100. Second constraint is 7X plus 12Y greater than or equal to 120. And this will always be there. Okay. So this here you don't have to solve the problem. Here you only have to formulate. See what is the question? Formulate the linear programming problem to minimize the daily expenditure or daily cost, expenditure or cost of sale. Okay? तो यहाँ अगर तो आपने देखा कि कैसे डेली लाइफ सिचुएशन को हम मैथमेटिकली सॉल्व कर सकते हैं. तो इफ यू सॉल्व दिस प्रॉब्लम बाय ग्राफिकल व्हिच वी हैव ऑलरेडी लर्न, you will know the values of X and Y. So you will know how many grams of food X a person should eat and how many grams of food Y he should eat in order to get his minimum dose of or minimum requirement of vitamins, and also which will minimize his cost. So क्योंकि cost भी देखना पड़ेगा ना, cost that should be minimized. Okay, so that solution we have already seen. So this gives you an idea कि linear programming problem का daily life में क्या application है. Okay, so this is one question which I have taken of formulating the linear programming problem to minimize the cost. Okay, I want to take one more where we are going to maximize the profit. Okay, in all the problems you read the question and put it in the tabular form. The data you put in the tabular form, because it becomes very easy. ये सब आपको लिखने का भी जरूरत नहीं. Now you will ask me कि this type of question how it can be asked in multiple choice online exam में. तो online exam में इसको इस तरह से पूछ सकते हैं. You may be given this data and you may be given 4 options. What is the objective function of this linear programming problem? तो अगर आपको मालूम है कैसे करना है तो you can easily find out the objective function. ये objective function है. या फिर आपको ये पूछ सकते हैं which of the following is a constraint of this linear programming problem. So if you don't know कैसे कंस्ट्रेंट बनाते हैं, तो you will not be able to answer that. Okay, and then it may also be asked which of the following is always or which of the following is always there in the linear program. Which constant? So this should always be there because x and y cannot be negative. Okay, so I hope you have understood. If you have got any question regarding this, just write out in the chat box if you have understood this. Have you understood this? Please write in the chat box. Ikra Ansari, you have understood? Okay, very good. Lakshmi Kengri. Lakshmi, have you understood this? Yes? Write in the chat box. Okay, so I'm getting some responses. Good. Okay, so let us take one more problem. Okay. What you have to do is just read the question, tabulate it, write the data in the tabular form. So every time you need not read it. Look at the second question. I'm reading the question. A factory manufactures two types of products. Now this problem is of manufacturing. Okay, so एक फैक्ट्री है जो दो तरह के प्रोडक्ट बनाती है, X and Y. Each product has to go through two machines, A and B. You know that कंपनी में जब कोई प्रोडक्शन होता है तो मशीनों से होता है. तो दो तरह के प्रोडक्ट है X and Y और उनको दोनों प्रोडक्ट को दो मशीनों से बनाया जाता है. मतलब मैन्युफैक्चरिंग के दौरान उनको दो मशीन से होकर गुजरना है. So each product has to go through two machines, A and B, in the process of manufacturing. Machine A can be operated for a total time of 12 hours. Now देखो मशीन की भी एक कैपेसिटी होती है. मशीन A कितनी देर तक ऑपरेट हो सकता है? 12 आवर्स होगी. अगर आपने उसको 12 घंटे से ज्यादा चलाया तो मशीन में कोलैप्स, इट में ब्रेक डाउन. ओके, तो मशीन A की कितनी कैपेसिटी है? It can be operated for maximum 12 hours, total time of 12 hours. 12 से ज्यादा घंटे चलाया तो खराब हो जाएगी. It takes 1 hour for each of the item X and Y. यानी एक आइटम और एक यूनिट ऑफ X को कितने घंटे लगते हैं मशीन A पर? 1 आवर लगता है. और Y का भी एक यूनिट को 1 आवर. दोनों तरह के प्रोडक्ट, हर एक प्रोडक्ट of X, एक प्रोडक्ट ऑफ X has to go through machine A for 1 hour और Y का भी एक प्रोडक्ट को 1 घंटा. Look at the second question, second sentence. Machine B can be operated for a total time of 15 hours. Machine B का मैक्सिमम कैपेसिटी कितना है? 15 आवर, 15 घंटे. 15 घंटे पे ज्यादा चलाया तो इट में ब्रेक डाउन. ओके, तो एट ए स्ट्रेच यू कैन ओनली operate machine B for 15 hours. And how much time it takes? For product X, it takes 5 hours. एक product of X type का 5 घंटे लेता है machine B पर और Y type का product 2 घंटे, 2 hours. So machine B can be operated for a total time of 15 hours and it takes 5 hours for product X and 2 hours for product Y. Okay. Now look at the profit. ये कंपनी जो है वो मैन्युफैक्चर करती है तो डेफिनेटली कंपनी विल लाइक टू गेट मोर प्रॉफिट, राइट? सो द प्रॉफिट पर यूनिट ऑफ एक्स इज ₹50. यानी एक यूनिट ऑफ एक्स के ऊपर कंपनी को कितना प्रॉफिट होता है? ₹50 का. एंड फॉर 1 यूनिट ऑफ प्रोडक्ट वाई उसके ऊपर उसको प्रॉफिट होता है ₹100 का. नाउ व्हाट यू हैव टू डू? Formulate the linear programming problem to maximize the profit. In the previous problem, we have minimized the cost. The linear programming problem was to minimize the cost. यहाँ पर profit है, तो profit definitely would like to maximize. So here we have to formulate the problem to maximize the profit. Okay. So as before, what are we going to do? We are going to prepare a table like this. Okay. So look at here. So सबसे पहले मैं क्या करूँगी? I'm going to assume that suppose the company manufacture X units of product X and Y units of product Y, because we don't know ना कितना यूनिट बना रहा है. So we will say let the factory manufactures X units of product X and Y units of product Y. Okay, and then we will make the linear programming problem with these two variables x and y. Okay, now let us see. So we will prepare a table like this. So in the first column, we'll write the product. So there are two products, x and y. X के कितने products बना रहे हैं? Number of units x and number of units small y for y. Okay. Now in the second column, what I'm writing, time required on machine A, as it is saying that both the products has to go through two machines, A and B. So in the second column, I'm writing time required on machine A. In the next column, time required on machine B. And in the last column, I'm writing the profit per unit. Profit will be in rupees. So profit in rupees per unit. So let us prepare the table. Read the question and write down the figures in the table. So read it. FFG manufactures two products X and Y. Each product has to go through two machines. So ये दो product हो गए, ये दो machine हो गया. A and B in the process of manufacturing. Machine A can be operated for a total time of 12 hours. So look at here. Available time of operation. This is the last row. So machine A का available time कितना है? 12 hours. So this is what I've written. This time will be in hours and profit will be in rupees. So time required on machine A, available time of machine A is 12 hours. And it takes 1 hour for each item of X and Y. So X का एक item को 1 hour लगता है machine A पर, और Y का भी 1 item को 1 hour लगता है. तो 1. Okay. Machine B can be operated for a total time of 15 hours. So machine B कितनी देर तक operate कर सकते हैं? 15 hours maximum. And it takes 5 hours for product X. तो product X का एक product of X के लिए machine B को 5 घंटे तक रन करना है. It takes 5 hours. And machine B and product 2 hours for product Y. So product Y के लिए 2 hours. Okay. And the profit for 1 unit of product X is rupees 50. So last column is profit. So X type के product का एक यूनिट के ऊपर 50 रुपीस का प्रॉफिट है, और Y टाइप के आइटम का एक यूनिट के ऊपर 100 रुपीस का प्रॉफिट है. So this is how I have converted this entire data in a tabular form. Okay. So the same table I have copied here. Look at here. Okay. ये देखो. Product, there are two products X and Y. Time, there are two machine, time required in hours, और machine A, machine B, and last column में profit, और यहाँ पर available time. ठीक है. Now what you have to do? सबसे पहले हम profit function, हम objective function निकालेंगे. So look at here. Profit on 1 unit of product X. Look at the table. एक यूनिट प्रोडक्ट एक्स का एक यूनिट के ऊपर कितना प्रॉफिट हो रहा है? ₹50 is ₹50. Correct. Therefore, how many units are manufactured? Number of units of product X is X. Therefore, profit on X units will be 50x. एक यूनिट के ऊपर 50 रुपए का प्रॉफिट है, 2 यूनिट पे 100, 3 पे 150. So X पे कितना? 50x. Okay. Similarly, profit on 1 unit of product Y. There are two types of product, no? Product Y is ₹100. एक product of Y, उसके ऊपर कितना profit मिल रहा है? 100 rupees. Therefore, profit on Y units. Product Y के कितने units बना रहे हैं? Y will be 100. Correct? So what is the total profit? Total profit is 50x plus 100y. Look at here. X units of product X का profit है 50x. Y unit of product Y का 100y. So total profit कितना हो गया? 50x plus 100y. So this is the objective function which is to be maximized. Is the objective function. Objective function which is to be maximized. Okay. So this is how I have written. Maximize Z equal to, and you know objective function we always denote by capital Z. So maximize Z equal to 50x plus 100y. So first part of the linear programming problem, that is objective function, we have found out. Now we want the constraints. So look at how are you going to get the constraint. Look at this column. मशीन ए उसका मैक्सिमम कितने देर तक चल सकती है, वो 12 से ज्यादा नहीं, लेकिन एक यूनिट ऑफ प्रोडक्ट एक्स को मशीन ए के ऊपर 1 आवर लगता है, तो एक्स यूनिट को कितना लगेगा, 1 टाइम्स एक्स, करेक्ट। सिमिलरली एक यूनिट ऑफ वाई, एक आइटम वाई टाइप का, उसको मशीन ए पे 1 घंटा लगता है, 1 आवर, है ना, तो y यूनिट को कितना आवर लगेगा, 1y, तो टोटल आवर्स ऑन मशीन A is 1x plus 1y. So let me write down that. So total time, number of hours, you can say time of 1 unit of product X. So how will we write? One unit of product X requires 1 hour on machine A, correct? Machine A. Therefore, X units of product X will require 1 into X. एक यूनिट को X 1 आवर लगता है, 2 यूनिट को 2 आवर्स लगेगा, 3 यूनिट को 3 आवर्स, X यूनिट को 1 into X आवर्स. Okay. Similarly, 1 unit of product Y requires how many hours? Look at here. Again, 1 hour. 1 hour on machine B. Machine A. Therefore, Y units of product Y will require 1 into Y, that is Y hour. So total hours on machine, therefore, total hours on machine A is how much? X plus Y. Okay. But machine A X units of product X बनाने के लिए X hours लगेगा, Y unit of product Y बनाने के लिए Y hour. लेकिन मशीन A कितने देर तक ऑपरेट कर सकते हैं? मैक्सिमम 12 आवर्स तक. तो ये जो आवर्स आ रहा है X plus Y total hours, it should not go beyond 12 hours. It can be maximum, it can be 12. It cannot be more than 12. So X plus Y is less than or equal to 12. So this is what is the first constraint. Okay. Similarly, you can find the second constraint in a similar way. Look at here. 1 unit of product X requires how much time on machine B? 5 hours. So 1 unit of product X requires 5 hours on machine. You can write similarly here. Requires 5 hours. So here we can change that. Here also in the same, I am making the changes. So 1 unit of product Y, product X requires 5 hours on machine B. Okay. And so X unit will require 5 into X, that is 5X. Similarly, 1 unit of product Y requires how many hours? 2 hours. 2 hours on machine B. Therefore, Y units will require 2 times Y, that is 2Y. So total hours on machine B will be how much? On machine B will be 5x plus 2y. देखो मशीन बी का ये कॉलम देखो, एक यूनिट के लिए 5 घंटे, तो x यूनिट के लिए 5x. सिमिलरली फॉर y, 1 यूनिट के लिए 2 आवर्स, तो y यूनिट के लिए 2y. सो टोटल आवर्स ऑन मशीन बी is 5x plus 2y. But machine B can be operated maximum time up to 15. Available time of operation for machine B is 15. So 5x plus 2y cannot exceed. मतलब ये जो hours है machine B पे, कि मैक्सिमम कितना होना चाहिए 15 से ज्यादा नहीं होना चाहिए. So 5x plus 2y less than or equal to 15. So this is what is the second constraint. Okay, so these are the two constraints here. And the last one, this will always be there, x and y. Why x and y cannot be negative? Because x is what? Number of items of type x, and y is number of items of type y which are manufactured. So that cannot be negative. You cannot say minus 5 items are produced, correct? Either 0 items are produced or any positive 5, 6, whatever. Okay, so x and y will always be non-negative. So the required linear programming problem is maximize z equal to the profit function 50x plus 100y and subject to these constraints, x plus y less than or equal to 12, 5x plus 2y less than or equal to 50. So I have taken both the type of problem. In the first one, we have minimized the cost, and the second, we have maximized the profit. So this has given you the idea what is the application of linear programming problem. Okay. So if this tabular form is given, then just you don't even have to write this. Just by looking at the table, you can easily you can find out the constraints as well as the objective function. Okay, so this just write down in the chat box if you have understood this. Hello. Okay, so this completes the topic of formulation of linear programming problem. Thank you all.